Alright, so in this video we're going to be going over how generics work in TypeScript. So they may look really scary, but we're going to be breaking them down, and I think you'll realize they're actually quite simple when you start from the beginning. So we're going to look at the most basic generic there is in TypeScript, I would say, which is the array. So in TypeScript we can say array, and then we can do these angle brackets, and we can put a type inside of it. So for example, I can say number. And so this is the generic part right here. Right? It's the type that we put in the angle brackets. So in this case, I said number. So I could say type is equal to num array. And now I've created a new type called num array, which you can see is an array of numbers. So the reason why this is called a generic is we can kind of put any type we want here, and that's going to change what the value is over here. Alright, so we have an array, and let's say we want a string array, we would do that. And now this type is a string array. And so we can put whatever type that we want here, and that affects what the end type is here. Alright, so how does this help us in practice? Where can we use generics? So we're going to start with a function and where this kind of helps to use generics. So I'm going to create a function called last. And what last is going to do is it's going to take an array of numbers. Alright, so this is my array of numbers type. I could also do the generic. Either one works. And then what I want to return is the last element of this array. So I'm going to say r.length minus 1. Alright, so what I'm going to do is I'm going to say last is equal to, or L is equal to last, and I'm going to pass in an array of 1, 2, 3. So what this is going to do, and if we look at this, this is going to be a number, and we can hover over last. What it's going to do is it's going to take our array of numbers, and it's going to return us back a number. So what if I want to do the same thing, but with a string array, right? Right, so it's going to tell me TypeScript that this doesn't work because I said this has to be an array of numbers. But our function doesn't really need to be specific to numbers. Our function here should be able to work with any type of array. So you may be thinking, alright, well, what we can do is we can say our array can be of anything. Okay, so now that works. TypeScript is happy, but the problem is we lose some of the type definition. So what do I mean by that? If I hover over what the variable L is, you can see it's of type any, and L2 is of type any. But we know if we're taking the last element here, this should be a number, and this should be a string. Alright, so this is where generics come into play. What we can do is we can say angle bracket t at the front here of our arrow function. And so t is a variable name, basically. Commonly you'll see it as t, but you can call it whatever you like. You could call it element, for example. You could use a longer name, but I'm going to use t. That's a lot of times what you'll see. And so what t stands for is the generic type that could be passed into our function. So I'm going to say this generic type here, I'm going to use that here. I could also do that as well. Those are equivalent. So what this is saying is I want to take a generic array. I don't know what the type is ahead of time. And so if we hover over this now, our function takes a generic type t and it returns the t type. So it takes an array of t and it returns t. So now if I hover over last here, you'll notice t is filled in. And in this case, number is what the generic type is. And if we look here, string is filled in, and you can see string is the generic type. So what that gives us is now when we call last on an array of numbers, we can see the value is a number, and when we call it on a string array, it's going to return a string back. And so you can see here's where generics can help us get more type definition or cover our code better, and we can see that TypeScript also inferred what the value was. I didn't have to say that this took an array of strings. It knew just based on this. It was able to infer it. But we can explicitly say it by saying string array right here. or well, in this case, we said this should be a single t, and then we said that the value is going to be an array there. So actually, this should just be string. All right, so I can explicitly say what the data type is or what the type is of my array. Also note, it's inferring what the return type is. We're returning t. We could explicitly say we're returning t as well. So that works as well. Okay, so this is a basic example of using generics. Let's look at another example, taking this to basically the next step. All right, so here I'm gonna make a function called makeArray. And so what makeArray does is, again, we can start with the non-generic version, is all I wanna do is take some value and return an array of it. All right, so here I have x as a number, and it's gonna return an array of numbers. All right, so now this is going to return me an array of numbers, and I pass 5 in. But now I'd really like to get this to work for a string value, right? If I pass in a, I want this to return me an array of strings. So whatever this type that I pass in, I want to return that type, but in an array form. So what would that look like here? Well, in our make array, we can make it generic. Can do t, pass the value of t here. And then it's going to infer that we're returning an array of t here. So now you can see this is a number array and this is a string array. Now again, we can explicitly say the return type. We're returning an array of t here if we like. But whenever I'm doing this, I don't usually say that. I just let TypeScript infer it if it's already correct. So we're not constrained to just using one generic type too. So for example, you can have a second one here. So here maybe I want to say t, and we'll say y is our second one. So I have x here, and say y is of the type y. All right, and then we're going to return xy. Okay, so I'm going to say 5, 6, ab. So we can see I passed in two integers, or two numbers, and our type here is a number, and the type here is a string with two strings. Now what happens if we mix this? So if we do v3, we can see that I have both a string and a number in here. And if I hover, I can see we now have an array of unions. So it's either a string or a number, and we have an array of them. So that's pretty cool. But let's say I didn't like how the inference worked. You'll notice that we're returning an array here. But really this is not an array, this is more of like a tuple. I'm just returning an array with two values. So what I could say here is this returns a tuple ty. Also, let's rename this to x so it matches better. All right, so we're taking two types, x and y. That's going to be our two params, and then we return those two params in an array. So if we hover over this, we can see that we have string comma number. Now, if we don't like what the generic type it inferred, for example, this was a string, I can override it like I did before. So string number. But let's say we want to have like a value that's either a string or null. This comes up a lot. So you could do something like that. So the first value could be a string or null. So in this case, you could pass null into there as well. All right, so that is how we can explicitly write the types here. Now let's say we, for some reason, only want to explicitly say what the type of this first one was. You notice it's going to get mad at us because it says expected two type arguments. So this matches here, and then what is the y type argument? We didn't pass that in. Well, we can either A, pass that in, right? Like put the value number that I just did, or we can actually set what the default type is. So by default, let's say I want to say this is a number, all right? So now if I hover over, you can see it says string or null comma number. You can also have this set to any is usually how you see this as the default value, but this is basically the default value of the type if none is specified. So yeah, if we don't specify default value, we have to put both of these if we put a single one. So we can either not override it at all, oops, and it's going to be happy, or if I start overriding the first value, I'm going to have to overwrite the second type argument as well if I did not pass in any optional ones up here. All right, so we went over doing two generics, how you can set the return value, overriding inferences, and the default value of type arguments. Let's go to extending these types. So let's say I want to constrain what the user can actually pass to the function, to the generic. All right, so let's say we have this function called make full name. And what this does is it takes an object, call it, and what it's going to return is the object, and it's going to also do object dot first name plus object dot last name. So what my function does is it takes an object, it keeps all the values that are already in that object, and it adds a new one called full name. It also expects that the object has the first name and the last name properties inside of it. So basically, I want to constrain the object to have these two values at least. So one thing I can do is maybe do an object, and you say first name is a string, last name is a string. Right? So that is one way you could do it. And if we look at what gets returned here, you can pass in an object like this, and then it's going to return those three values. So we have our v4. You can say make full name. You can pass in the first name Bob, last name Junior. You can pass it in like that, but what happens if I want to accept objects that have these two properties but maybe more? So like maybe it also has age, which is 15. Right? So now it's going to get mad at me. It's going to say age does not exist on this parameter. So how can I allow any object to be passed in to this function that has at least these two fields? Well, that's when we can do a generic. So I can say t, and the value of object is now t, but I also want to put some constraints on the generic type. I want to say this generic has at least a first name and a last name field. So what I can do is I can say extends an object which has a first name of string and a last name of string. All right. So basically I put some constraints on what this type could be, possibly be. So what that means is this works, but let's say I have, I don't know, another, right? We just pass it another field. We don't have a first name and a last name in this object, so it's going to say there's some kind of problem with it. And the cool thing about this is if we hover over our v4 now, we can see that there's an age property, a first name, a full name, and a last name. So it correctly kept all the properties on the object and added a full name property to it. So that's pretty cool. All right, so that is how you can use extends. Now you can extend other things besides objects, but personally I tend to do objects the most in this kind of scenario. But just note you can also do it for other things as well. All right, so we did that. Let's also jump into interfaces and how you can do generics with an interface. All right, so I have interface, and let's say we have a tab. So our tab can have an ID, which is a string, and a position, which is a number, and then some data. And we don't really know what this data could be. Maybe some tabs we want to have one value, and another tab we want different value. So this is another one where we could either put the word any, or maybe we want to take a generic. So if we want to take a generic, we can use our angle brackets right here, and then the name of the type. So I'm going to call it t. We can pass the t in there. And then here I can say number tab is equal to tab t, or sorry, tab number. And this should be type. Oops, there we go. So this is me creating a new type, which we can see is a tab, which is number. So this is equivalent to me saying number tab. And then putting the word number here. So these two statements are equivalent, and we just basically are inserting the number in where the t value is. So now for my type here, let's say I want to do a string tab now. So we'll do that. And we can do that. And now we can easily create different types of types this way. So this comes in handy when you kind of want to make a few different types of types that inherit from kind of a base like this. And there's like a generic type that we want to pass in. So that's another option where you can use generics with types to create new types. All right, so now I want to get into some more practical examples. I'm going to be focusing on React because that's where I tend to use it the most. So we're going to start with props. So in React, if I want to create a component, hello world, I say react.fc, and then I create an interface called props, and maybe I say name, which is a string. Right? And I put the angle brackets here. So this is a case where React created type definitions or interfaces where they take a generic, and their generic is what the props are, because the props are going to be generic. They don't know ahead of time all the data that you want to pass into your component. So in this case, we can say we want our component here to take a name. And now we get type definition for the name there, and we can return a div. You can say hello name, right? So that is where generics are used in React. Another case is if you want to say use state. So this is a hook in React. So here the argument is a generic. So I can pass in, say, an object, which is name, which let's say is a string. So if I hover over this now, well, this is kind of a messy one. You can just do state. Say state.name is available, but if I change this to full name, name doesn't exist anymore and full name is there. So it knows that because useState takes a generic. And I can overwrite that generic by putting brackets here. So this is where it's good to know how the overriding of generics work, where you can actually explicitly say what the value is. Because maybe I really want to say the full name can be a string or it can be null. So you can do something like that. And now we've explicitly said what the type of this parameter is. Okay, so that'll come up when you're using hooks. And then lastly, I wanted to go over generics when using like JSX or components. So this last thing I use sparingly, but it does come up now and then. So let's say we want to create a form component. We're going to call this form. Yeah, we'll just call it form. And this is something that I saw Formic do. So basically, we want our form component to take, and we're going to call this interface form props, some values. Now each form is going to have different values in it. So I want to make this actually a generic. So I'm going to say t. Oops. So we'll use our angle brackets here to say this interface takes a generic t value and this has some values in it. Now I'm not going to do the FC here because I want to actually make this a render prop. So what I'm going to say is this also returns some children. So we're going to say jsx.element, and we're going to pass down the values, which is the value of t. So what this will allow you to do is now in our form here, we're going to say form props. And now we need to pass in what the value of this is. And that's where we're going to use another generic right here. So this is how we can make our React component use a generic. So now here I'm going to say extends an empty object because we want it to at least be an object that's being passed in. Also, just good to note, this doesn't seem to work if you don't extend something here. Alright, so now here, let's say I have values and children. I can return children and values. Alright, so what does this guy do at the end of the day? Well, let's actually try rendering this. So form, and I said this was a render prop. And let's say we want to have a div here that says hello. Alright, so the first thing you'll see is it tells us we need to pass in a values here. Alright, so let's say values is a first name Bob. Alright, so this is my value that I want to pass into my form. And now the cool thing is the values here. You can say values dot, and now you can see first name shows up here. And now whatever value I pass into the values here, last name, it's now going to have that same set of properties on the parameter that we get here. So now we get last name. So that's how libraries like Formic do it, where you're able to get the same type as was passed in here. Now TypeScript again is inferring this type. We can actually explicitly override it by putting a bracket here. And we can say last name is a string, or maybe it's null, right? So now we've overridden what the properties are. So this is how you can do generics in JSX. So here we have our angle bracket, and so this is where you put your angle bracket if you're doing JSX. So you stick it right there, right after the name of the component, and then you put your type in there. So in my case, it's an object which has a last name, which is either a string or null. So then we could pass in null if we wanted to here. And again, because we explicitly said the type, what the type was here, it's going to tell us, hey, that doesn't line up. You said there's a last name which is string or null, but you didn't pass it in. So now we can enforce that. So there you go. That is an introduction into generics. Hopefully that helped give you a few ideas of how you could use them in your code and how you can use them in React.